Hello and welcome to this fifth edition of Machine Design and Machine Shop Operations. Now today I'm going to be showing you the measuring results of the drill bits. So not long ago I made a post on Instagram where I basically stated that one of the drill bits I had was strangely, I think it was smaller or maybe it was larger, but it was not what it was supposed to be when I measured at a certain point on it. But it was pointed out to me by some of the audience that actually drill bits generally are supposed to be slightly larger at the tip than they are at the base. So I thought, well, let's look into this. Let's really find out. Let's get to the bottom of this. The two essential questions: is that true? Are most of them like that? And the second question is, if so, then how much difference really is there? So I've been able to determine that. So now what I've done here is I've listed all the sizes of the drill bits that I've been measuring. I've got this big pack of drill bits, and only have imperial micrometer, unfortunately. So I've had to measure these metric drill bits in imperial, but don't worry because I have converted them all into metric from the imperial measurement. So just before I show you that, I should say that if it equals something negative, that means it's larger at the tip. And if it's positive, it means it's larger at the base. And if zero, obviously, there's no difference between the top and the bottom. Now, I double checked these measurements, and so I have a good amount of confidence in them. So, also, I should just mention before I move on, if it says NA here, that just means that there's either a drill bit missing from the pack or there was something wrong with the drill bit. So, here we are. Now, I will state that I definitely went overkill with this, going 4 places after the decimal points. This is in millimeters. This is not imperial, so that really is quite a small amount. You're looking at there, 6/10,000ths of a millimeter is just absolutely ridiculously tiny. But nonetheless, here we go. So you can see just by looking at this now that most of these are negative. You see here equals negative. So 0.0254, that's 1 thou. So you're seeing a lot of 0.0254s and a lot of 0.0127s. Then on the negative, So what I did with these results is I actually calculated some percentages here. So measurable total, right? So what I mean by that is obviously I didn't measure the ones that had something wrong with them, or if they were just missing. So there's 47 in total. The ones that had zero difference, there was 13 of them, 1 positive, and 33 negative, which means there's 33 of them that were larger at the tip. Which is, as my audience had said, So put them into percentages here. 70%, well, just over 70% is larger at the tip. So that answers the first question, is there generally a difference? Yes, there is. Most of them are larger at the tip. Now, the second question, I would say that the most that is different, I found it was 0.0225 millimeters, I think it was. That was the largest difference that I found. So, no, was it? Actually, let's just check. Hold on. Where was it? Let's see what the largest one was. The largest difference. Yeah, there it is. Okay, yeah, that's the largest difference. 0.0635. Sorry, that's in millimeters. So, that's still a very small amount. But I'm not sure if that's a surprise to any of you. It's not really a surprise to me. Makes me wonder if that was just maybe a quality control issue. Don't know. So that answers the second question, But one observation I did make from this, just myself, is if you notice, look, most of the zeros are occurring at the smaller drill bit sizes. It becomes less and less common for you to see a zero as you go through the larger sizes, into the larger sizes. So I thought that was interesting. Maybe some of you will know why. If you do, please tell me. But yeah, I hope this has been of some interest, and thank you and goodbye.